In this example, we have a switch that closes at t equals 0. We want to find the current I out of this 12 volt source for time less than 0 and time greater than 0. First, I'll do time less than 0. I find it's easier to always redraw the circuit for the time period of interest when I've got a switch in the circuit. So in this case, I've got a 15 ohm resistor. The switch is now an open circuit. It's my 12 volt source and my two 20 ohm resistors. If the switch here is an open circuit, the current through that will be 0. That means that this entire current I is going in this direction. And we can essentially forget about what's going on over here. If I do KVL around this loop, these two 20 ohm resistors are in parallel. So the equivalent resistance, Req, is equal to the product of the two, 20 ohms times 20 ohms, over the sum of the two, 20 ohms plus 20 ohms. 20 times 20 is 400 over 40 is equal to 10 ohms. Now the circuit looks like this. I have a 12 volt source. It sees, as far as the current is concerned, a 10 ohm resistor, and this is the current I. So by Ohm's law, I is equal to 12 volts over 10 ohms, which is 1.2 amps. Now let's do the problem for time greater than 0. For time greater than 0, again, I'll redraw the circuit. Now the switch is a short circuit after it's closed. Now if I draw this loop, it goes through only two resistors. The two 20 ohm resistors are still in parallel. If I draw a loop through here, goes through only this 15 ohm resistor and this 20 ohm resistor, so those two resistors are in parallel, and in fact any loop that you draw indicates that all four of these circuit elements are in parallel. I've already calculated the equivalent resistance of these two 20 ohm resistors in parallel. That was 10 ohms, so the 20 times 20 over 20 plus 20, and the circuit becomes this. 15 ohm resistor in parallel with a 12 volt source, which is then in parallel with an equivalent 10 ohm resistor. These two are in parallel, so the equivalent resistance seen by the source is the product of the two, 15 ohms times 10 ohms over 15 ohms plus 10 ohms. 150 over 25 is 6. Now the circuit is simply a 12 volt source with a single equivalent resistance, which is 6 ohms, and this is the current I that I want. By Ohm's law, I is equal to the voltage, 12 volts, over the resistance, 6 ohms, which is 2 amps.